All right, 13. So we're given this graph. We're given this graph. The forces shown in the force versus time diagram act on a 1.5 kilogram particle. So we'll say it's like a box like this. Shut it. Okay, so we got a 1.5 kilogram box. There's some force acting on this box. Does this force remain 100% constant? No. So notice that the force starts out at 4 newtons, right? 4 newtons for the first 3 seconds, but then the force immediately drops to -2. Now what does that mean? So the force here, it starts out as 4 newtons positive, meaning to the right, negative to the left. So what happens at t equals 3? What's going on right here? The force changes from 4 to what? -2. What does negative mean? To the left. So basically, like, what's happening here? For the first 3 seconds, the object is accelerating in the positive direction. Then, from 3 seconds to 5 seconds, it's decelerating. Does that make sense? Yeah. Okay, so that's kind of an overview of what's happening. Okay, A, find the impulse. So let me just revert this. Okay, find the impulse for the interval from 0 to 3 seconds. So impulse is change of momentum. On a force time graph, that's the area. So from 0 to 3, what we want to do is calculate this area under the graph. So for A, impulse is basically equal to force multiplied by time. The force is 4 newtons. The time is 3 seconds. So this gives us an impulse of 12 newton times second, which is the same as 12 kilogram meters per second. Like that. So that's the answer to part A. It's positive. That's a positive answer. Okay, B. What's the impulse from 0 to 5 seconds? Now here's the thing. So the impulse for this first part right here, where I'm erasing, the impulse in here was 12. Now, what's the impulse in here? Well, you got to calculate the area of that little rectangle. So what's the area of that going to be? It's going to be 2 times 2, which is what? 4, but it's negative. Why is that -4? Because this force right here is negative. It basically just means opposite motion. So the total impulse is going to be 12 plus a -4, so 12 kilogram meter per second plus -4 kilogram meter per second gives us positive 8 kilogram meter per second. So that's the impulse for the full 5 seconds. Okay. Now, part C. If the forces act on a 1.5 kilogram particle that is initially at rest, so V initial is 0, right? That's important. Initially at rest. Find the particle speed at t equals 3 and t equals 5. So here's where you go. Change of momentum is mvf minus mv initial, right? Because what's momentum? mv. So final momentum would be mvf. Initial momentum would be mv initial. What do we know about the initial velocity? It's 0 right here. It says initially at rest. That's 0. So v final is going to be change of momentum over m. So the change of momentum for, let's see, at t equals 3, what was the impulse? 12. So this would be 12 kilogram meter per second over 1.5 kilograms. The kilograms cancel and we get 8 meter per second. That's the velocity at 3. Now, how do we get the velocity at t equals 5 over here? Well, what was the change of momentum for the whole 5 seconds? Change the 12 to what? To 8. So change the 12 to 8, and then that answer becomes, so I guess I should erase this. So it now becomes 5.3. So at t equals 3, it's going 8 meter per second. At t equals 5, it's going 5.3 meter per second.